G'day, my name is David Liebernight and I'm here to show you just how easy it is to use MyTorch. This is a drop-in replacement for PyTorch that automatically uses our cloud GPUs. No infrastructure setup, not a single line of code that you need to change, no extra DevOps or config. It just works out of the box. So before we go into the demo, let me show you how easy it is to get this set up. Just a few lines of code. So first you need to get your access token from mytorch.net and you put it into a file like this shown here. And you need to set up your environment correctly. The magic is that you install MyTorch instead of PyTorch. So you set up a virtual environment and you activate it and you pip install MyTorch AI. You do that instead of Torch, and that's really it. So I'm going to show you an example in a Jupyter Notebook today. You can also use plain old Python code, but it makes a nicer demo to use a Jupyter Notebook, so let's do that. So here it is, you can see here. And one other important detail, you need to select the right kernel, which is the Python MyTorch kernel. And the way you set that up is like this. You can see that right here. This is the code that you would have to type, and that's it. You can clone our examples repository and set up Jupyter Notebook and launch it and select this kernel, and you're good to go. You can run this exact same example that I have here. So here's the demo. In the first cell, what we do is we import some libraries just like you normally would for any PyTorch application. But what's different here is that you can see we have a GPU. We're connected to MyTorch server and we're using a GPU in the cloud. But notice that there's absolutely nothing in this Jupyter Notebook cell that specifies any of that infrastructure. This is just plain old vanilla Python and PyTorch code, and it just works out of the box. So our demo today will be simulating detecting a water leak. So we're going to make some dummy data and train a model and then run the model to detect leaks. So this is like what you might do in the real world for an edge device, but a Raspberry Pi does not have a GPU, right? So with MyTorch, you'll be able to run that on a Raspberry Pi and automatically go to the cloud and use our GPU chip without changing a single line of code. It's really quite cool and powerful. So this cell here just generates some dummy data, and we'll visualize that. Here's basically what it looks like. We've got normal water usage centers around about 2 liters a day. So this is 24 hours worth of water data. And our anomalies that we're going to try to detect are just spikes in the data. Yeah, it's a dummy application, but it's simple and it demonstrates just how easy it is to use MyTorch. So here in this cell, we prepare the data in the standard way, basic data science. We set up a data loader, tensor data sets, just like you normally would. And in this cell, we define our auto encoder model. It's an encoder-decoder model, which is good for detecting anomalies. Basically, you take the 24-hour data set and you squeeze it down to a smaller dimension, which forces the model to learn the most salient characteristics of the data for normal data, and then when it tries to reconstruct it in the decoder, if it gets a large enough error, then that's an anomaly. Basically, a very simplified explanation for how it works. So we can set up that model here in a cell, and we can run this training loop, which is a standard training loop for a model of this kind. And you can see that when we run that cell for a number of epochs, it learns, so that the training loss and test loss continue to decrease as you would expect to show learning, and we'll graph that. So here's what the data looks like that basically shows that the model has learned and is converging. You guys know AI. I don't really need to explain all of this. Again, the point is just that this is all generic PyTorch code and it's running in the cloud. Now, if we take that model that we just trained and actually run it to detect anomalies like this, again, standard PyTorch code, it works, and then here's the results of that. We can plot them just like you normally would. This gives us an accuracy of 97%, which is quite good, especially for a small model that has only been trained for 10 epochs, because it's a pretty simple problem that we've given it. For a real water leak detection application, we'd probably have a bigger model and some more sophisticated data science, but this gets the point across. We've detected 180 out of 180 normals, 14 out of 14 anomalies, but we missed 6. So our score isn't perfect, but it's pretty good. And here is a visualization of that reconstruction error. So the model has learned a threshold, which is based on a standard deviation statistical technique for how big the error is of the reconstruction from the encoder-decoder model, and this is a representation of that. And that's it for the demo. So just to recap, we have registered at mytorch.net to get a access token and put that into the right place as shown above. And we have correctly set up our environment to use MyTorch AI instead of Torch. And that's it. How cool is that? Thank you for your attention, and go out and use MyTorch. It's the future of AI, scalable applications with zero friction. It just works out of the box. Thank you.